Hello and welcome to Cotton Innovations Limited. We're looking at the study of design of experiments, and this is a series of five videos that are talking about design of experiments. How do they work? What is it you need to do? How do you prepare for doing a design of experiment, and equally how do you extract all that key information? What we've looked at so far is we've looked at three factors, A, B and C. We've looked at if we had main effects, which would be the A, the B or the C. We'd be looking at this factor against that factor against this factor. If however there was an interaction, A against B against C, it would be the sides of the cubes, or the back or the front or the bottom or the top of the cube, where we would be having the interaction. Or if it was a three-way effect, an A, B and C altogether, we would be looking at inside that cube. And we looked at the cup of tea in the last video of what do we mean by an interaction, and we discussed how sugar, if it's not stirred, will not make a sweet cup of tea, but it's the interaction of sugar and stirring and hot water that makes for a good cup of tea. Each element on its own will not actually make for a good cup of tea. So now we want to look at defining the levels. What do we mean by defining the levels? Well, there's two things you need to understand is when you're looking at setting up your design of experiment, what is the lowest value in your cube? So this would be low and this would be high. So what do we mean by low? Well, I need a level where all of a sudden it just starts to work, it just starts to operate, and I need a level where it's too high. So we need to first of all plot out those factors. So this would be factor A, and these might be my increments of factor A. I need to test it at this point, this point, this point, this point. So for example, we were talking about the thermal weld of a plastic form. That thermal weld will have a minimum temperature and a maximum temperature. So I would need to know what is the minimum. So maybe we're working in degrees centigrade. So degrees centigrade, we would say it would be 130, 140, this would be 150, this would be 160, that would be 170, and this one here would be 180. So we're going to go from a temperature of 130 to 180, and we want to know how well does it weld with that temperature. Then we need to have some effect here, which is our output for factor A, and this would be the tear strength, this would be the separation force, this would be the adhesion quality. And we might be measuring that in newtons, we might be measuring that in some other method. But for now we'll call it newtons, and we'll call it 10 newtons, 20 newtons, 30 newtons, 40 newtons and 50 newtons. So we want to see how this works. Now when we actually do our test, what we might find is the data looks something like that. Okay. Now this curve will always depend on the type of plastic that you're using, the type of iron that you're using, the surface area that you're welding, the thickness of the materials, the thickness of the card. All those things will affect what this curve looks like. So if we were to set 2 points, we were to choose this point here at 130, and we were to choose this point here at 180, our experiment would be looking at those 2 points there. The experiment would run fine, the data we would get would be fine, it would be absolutely brilliant. However, the model needed to follow the blue line. The model is actually following the red line. So we need to make a decision. Do we, first of all, ignore this one, which is the right thing to do, and do we set this experiment up here, and we run it between this point and this point? Or do we set it here and run it between this point and this point? Why those 2 points? Well, this is linear and that is linear, which means the amount of error we'll get in our experiment is really small. So then I need to do some further investigation work to find out what's going on here. And what I find is that when I look at the quality of the weld, it's not always welding well at 130. So it's actually 145 where we start to get a good weld. So everything in this area here, we have to start rejecting because there is an uncertainty that's going to come into our experiment, which will be difficult to understand. Equally, one of the things I want to understand is at what point do we start to burn or wrinkle the plastic, or so that it doesn't look like a good weld, it's over welded, it's melting the plastic. And we find at this point here, the material itself is actually failing. So now we've got two things that we've learned. We've got a weld profile, we've got a minimum and a maximum that we could choose that are both linear, but in actual fact, the place we want to put our experiment is in this area here. Because in this area here, we will always get a good weld. Now, because there's a curve here, we need to start thinking about how we're going to deal with that. There's two ways we can deal with it. One is we can go to a 3-level design, which is a great thing to use. Unfortunately, it multiplies the number of experiments by the cube instead of by the square. So instead of having 2 experiments, which equals 4 tests, 2 experiments is going to, then 3 experiments, so A, B and C, would require 8 tests, and then 4 would equal 16. This is going up by the power. If we were to consider the cube, 2 would put us at 9, 3 would put us at 27, and 4 would put us at 81, which immediately is too many experiments. So what we can do is we can use 3-level design, not always the best thing to do, or we could use what's called a center point. So we can choose a point here, we're going to choose this point here, we're going to choose this point here, and then we're going to choose a center point which is equidistant to both of those points. So effectively we create that curve using a center point. It requires less experiments to run that. It's not as robust as a 3-way design, but it gets us into a good place. If you'd like to know more about selecting your levels, selecting your design criteria, how many tests that you require, how to optimize the number of runs that you need to do, bearing in mind that all of this takes time and money, please reach out to us at Cotton Innovations Limited. Details are on the screen. We'd love to help you design your experiment, help you run that experiment, and help you deliver the solutions that you're trying to find. Thank you so much for watching. We hope this has been useful for you. Please reach out and we will help you with whatever it is you're trying to do. Thank you very much. Goodbye.